Good afternoon. Can you hear me okay? Hello. Testing. 1, 2, 3. Yeah. Okay. Okay, we'll get started. I'm Anjal Bhambre, and I'm from IBM, leading the Big Data Initiative. So today, we are going to talk about getting Hadoop ready for the enterprise. And I'm going to take a slightly different angle here. I know you've, over the last, I guess, a day and a half, you've heard a lot about what is being done at the core Apache Hadoop layer to get it ready for the enterprise. As we've been working with customers and seeing how they are using Hadoop in the enterprise, there is stuff that has to be done to build the stack up, starting from Apache Hadoop up and around. So the focus of my talk is going to be on that facet of making Hadoop ready and stick in the enterprise so that different classes of applications can run and leverage all the good work that has been done by the Apache Hadoop community. So that's what we'll start with. I think we would all agree that these are pretty exciting times. I was just talking to an ex-colleague of mine that if from it doesn't matter whether you're working on really building building software products or using them to build applications, big data is really where you want to be. I don't think we would all agree, we haven't seen anything quite like this where every click, every interaction, every breath, everything is being captured. So this is the new world, and obviously it's nice where I want to welcome you to the world of big data. From the standpoint of what the possibilities are with big data, we'll spend looking at some of those applications. But just like in terms of when you look at that, if you have oil, if you cannot process or refine it, then it's not useful. So the same thing applies to data. That big data, if it is just left on disks or on your over the wire and is just treated as bits and bytes, then it's of very little value. But if you can extract it and process it and refine it, that's when you start getting meaningful insights from it. When we look at the characteristics of big data, I think if you heard Merv at the keynote yesterday, he mentioned, right, the volume, which is the size of the data that we are seeing is huge. For some of us who've been in the warehousing space, it was pretty typical that a lot of the warehouses were almost under 50 terabytes. At the beginning, they were like less than 10 terabytes in size. But now when people start, they start with petabytes of data. So certainly the volume is just phenomenal here that has to be handled. Same thing in terms of the other aspect of the characteristic is the velocity or the dynamics or the speed at which this data is not just getting generated, but is also needs to get processed. It's coming from a variety of sources. So it's structured, semi-structured, unstructured data. And then there is the veracity or the quality of this data. That itself sometimes is not clear that, is it really good or bad data? What's the noise to signal ratio? And all those aspects are very critical because sometimes if you just pick the wrong data and use an approach that we'll torture this data enough till we get meaningful insights, that is not going to work. So the key in all of this that when we are handling these different aspects of data, what is key that is really making that the new applications happen? One key aspect is really getting a 360-degree view of different entities to get a holistic view of that entity is really creating new insights. Now, this 360-degree view of an entity could be a customer, this could be a patient, it could be a fraudster, but the holistic view is what is really helping get to new insights. And we look at a few examples here. According to the World Health Organization, there are 15 million premature babies born every year. And of these 15 million, close to 1 million die within the first 30 days. So their lifespan is 30 days. And that's a pretty sad situation. And it's not that a lot of these babies are not getting any care. A lot of them are in the neonatal centers. So there is a lot of data that is being gathered about them. There are doctors and nurses trying to take care of them. But what has been happening up until now is that even though a lot of the data which relates to the blood pressure of a baby, the pulse rate, lots of KPIs like this was gathered, but it was turned into, by sampling some of this data, aggregated into 2 or 3 readings, which the doctors and nurses on rounds would see and would determine just by looking at that sampling and aggregation that the baby is doing fine. Now, what we did was and we'll get into the technology after looking at some of these examples. We helped analyze, in this particular case, the University of Ontario in Toronto, almost 1,000 pieces of information that were being gathered per second per baby, and process that, see the patterns, show those patterns and correlations to the doctors and physicians, and correlate that information with the notes that doctors and nurses would scribble as they would be on rounds, the family history of the patient. And by correlating all of this information, the net result was being able to predict the onset of an infection in a newborn baby 24 hours in advance, which is a huge amount of runway in the case of a premature baby. And so in this case, it's same data that was available before, but now that it can be analyzed and processed at the speed needed, it's resulting in saving lives. So this is the impact that big data is having on human life. Looking at a slightly different example here, this is a company doing for a lot of the SMB customers. They run their marketing campaigns via emails. So their challenge was that how do you send the email at the right date and the right time so that you have a higher conversion rate. So in terms of volume, they had to analyze 35 billion emails a year. And at this point, they were looking at the insights that they gleaned from this was what's the right time to send that email so that there would be a higher conversion rate. And the next step here is going to be that actually analyzing the content of the email itself. So in the first phase, where they could just get that valuable insight that when you send the email at this time to certain individuals, that's when the chances of them really clicking and opening and reading that email are much higher than if you send it at a wrong time. And it increased their conversion rate by 15 to 25%. So these are real returns that customers are seeing by leveraging a lot of the technology that we are hearing about at this conference, plus more. This is an automotive, an example from an automotive industry, where again, lot of data which was being collected on the assembly line. This is data which is from the parts and equipment that is passing on the assembly line. And being able to analyze it and see patterns, they could catch defects in those parts before they left the factory itself. So that was one outcome of this. The second thing that they were able to do was gathering and analyzing telemetry data and in-vehicle sensor data, and being able to predict that which part or what issues might arise, so that they can do preventive alerts to the customers and in turn improve customer satisfaction. So these are just a couple of examples. These are all actual deployments that we have seen of where people are leveraging big data technology in a manner that was just not possible before for a variety of reasons, and we'll get into some of those. So when we look at that, okay, so obviously all of this is possible because of the technology innovation. It's now possible that you can have in your enterprise a big data platform where you can ingest, bring in all these different kinds of data and do it in a cost-effective manner. I think there was a comment made in the keynote yesterday that instead of having multiple copies of the data, you can have the data in a big data platform which is ready for exploration. But you can put this data or leverage this data for different kinds of applications, different kinds of usage. But every kind of usage doesn't require that you have different silos of the data. Now, on this, on the platform, you can capture structured data, semi-structured data, unstructured data. So this data could be in large volumes coming from all kinds of sources, being generated at a very fast speed. And this can all land in one place. And then, of course, what this has done is that once all this data is in this big data platform, it has created a new class of diviners, I would call them, which are the data scientists, that this data needs to be explored, this data needs to be analyzed, filtered, right pieces of information need to be extracted to really see what's good and bad about this. And so there is definitely a new class of role emerging here, which is, we've heard a lot about those, that's the data scientists. So a lot of organizations that need to gain new insights are bringing in people who can do this once the data has landed on a big data platform. And as these new insights are gained, they have to be made consumable so that the line of business can see what is the value from these insights. In some sense, making these insights actionable. So spotting the trend setters, understanding more about your customer and your consumer, detecting fraud better, more accurate, more quickly, and so there is new classes of applications that are emerging to really make these insights consumable by the line of business. A very common pattern that we are seeing in terms of how is the IT infrastructure evolving to deal with big data. This is a reflection, I would just call it like a blueprint of that. That what we would like if you go back many years. It was, I guess the world was a little simpler from an IT standpoint, that you had applications and they were being serviced. The requests that the applications made were serviced by operational data stores or your CRM, ERP, wherever that data is captured. And then, of course, we saw this whole trend when we look at the whole evolution, that from these operational data stores, data was ETL'd into warehouses. Then on the warehouses, people were doing statistical analytics, descriptive analytics, building predictive models on some sample of the data to predict outcomes. And as the sizes of the warehouses were growing and reaching sort of tens of terabytes, that's when sort of push down of this model building and scoring started happening in the database itself. But then what we started seeing is more and more that Hadoop started showing up in these enterprises more on that it was still not on critical path, but where customers were looking at that they would have their hot data on which they need to run their reports on maybe a daily basis, maybe keep that hot data in the warehouse, but really offload some of the data that they don't know whether they'll need it ever, or they might need it sometime in the future, offload it or push it off to some, a Hadoop file system, for example. So that has become what you see like on the left-hand side, bottom, which is really sort of like an active queryable archive. So this was still, that Hadoop was still not on a critical path here. But as people realized, and based on especially what's happening in the last 2 to 3 years, where it was very important that for enterprises where they say, we understand our customer, well, a lot of what they needed to understand about the customer was not in their warehouse. It was outside their enterprise. It was in the social media. It was, captured maybe in the email interaction that they had with the customer. It could be a call that was made to their call center. So there was data which was outside the warehouse, whether inside the enterprise or outside the enterprise, that became critical, like we said, to build that 360-degree view of the entity that they were trying to understand. And a lot of this data was not structured data, semi-structured, unstructured data. That started obviously making its way into Hadoop. And so we were seeing that now Hadoop is becoming a polystructured store. So this data, and then of course, as there has been, I'm sure there are some of you in the audience that have been working in this whole Apache Hadoop space, but a very vibrant community has emerged and made a lot of things possible directly to take place on this polystructured store. And that's when people started calling this the analytics sandbox. So it still wasn't on the critical path, where when I was talking about that a new class of diviners started emerging, where people started really exploring the data while it's still in this landing zone. So ingesting all of this data, offloading or archiving from the warehouse, but also bringing in data from the sources that you see on the left-hand side, which could have been inside or outside the enterprise. And once all this data came in, and it was stored in the file system, then there was a need that this, like, what is really important or what is really useful in this data. So data transformations and analytics had to be done on this data, leveraging MapReduce so that you can do it in parallel on massive amount of data. And finally, once after you've done that, it got condensed into something that you feel you would care about. And that's when it started landing in things like HBase or other column stores. And with that, once the data lands there is some structure to this data. And then you need a way to index and query and search this data. And the other thing that has been happening is that, like we talked about before, that when people were just building or bringing in data in the warehouse and it was all relational data, they were building predictive models on a subset of the data. So, but with a low-cost offering like having all of this data in Hadoop, it became possible that now you can build those predictive models, not that on a subset of the data, but on all the data that you need to improve the quality of your models. So building those models, scoring those models, saving results of those models, and comparing that as you bring in more variables and dimensions to the models, is the quality of the models really improving. So being able to do all that became now possible. So which is where this analytics sandbox started becoming pretty it has started to become pretty relevant in the enterprise. So when we hear that every enterprise has some Hadoop in the enterprise, at least it's starting there is what we are seeing, right? That either people are offloading from their warehouses so that they can treat this as an active queryable archive, or they're also bringing in data which was before either not being analyzed or not being correlated with the data in the warehouse, and be able to develop applications to do ad hoc kind of analytics on your Hadoop system. Now, as these predictive models were developed or are being developed, in a lot of times, right, so we talked about sort of the bottom side of the picture. And in big data, there is a lot of data that is getting generated very quickly, right, at a very fast pace, and actions have to be taken on this data in real time. So one very important aspect of, as people are leveraging, getting their arms around big data, is being able to analyze this data in real time with extremely low latency. And so that's where the top picture comes in play, where we are seeing a lot in the telco industry, for example, where billions of call data records have to be analyzed. And if the previous approach was that as these call data records come in, there is a standard ETL that happens, and it may take 2 or 3 weeks before the information that was needed to be populated in the warehouse actually lands in the warehouse. Now, what is happening now is that the volumes of these call data records, it's just exploding, right? That these telcos have a need to process maybe 10 billion call data records every day. And these have to be processed, insights have to be gained from it, and actions have to be taken, and they cannot wait for 2 to 3 weeks for that to happen. Customer churn is an example, right? If it takes 3 weeks for a telco to figure out that a customer is going to churn, that might be too late. So what we are seeing is that for a different class of applications where you have to process, again, it's not just about structured data, it could be any kind of data, it could be video streams, it could be text, it could be voice, that has to be processed in real time, and actions have to be taken. That's where the real-time streaming capabilities come into the picture. So the example that I had shared earlier about Data Baby, that leverages the streams technology, and where information has to be processed in real time, because to be able to predict an infection 24 hours in advance, if one were to wait to put all that data in the warehouse and it takes 3 to 4 weeks, we just said that according to the World Health Organization, 1 million babies die every year, premature babies, within the 30 days. So there is no window to, unless you do it in real time, there is, and those kinds of use cases may apply to other situations as well. So again, one very sort of a pattern that is emerging is that as people are building these predictive models by doing historical analysis in their Hadoop system, they can then score those models in real time as the data streams are coming in. So that, because the building of the model is not going to take place in real time. The building of the model, the quality of that model, the testing of the model all has to happen in a separate window, and in a separate, it has a life cycle of its own. But when you need to score the model, that is now possible to do it in real time. So I mean, this is a very common pattern that we are seeing enterprise after enterprise, industry after industry. So I thought it would be useful to put it up there to share with all of you today. Again, there are obviously lots of use cases, possibilities. Based on the engagements that we have done with customers, these are the top 5 use cases that we are seeing emerge in the industry. And while the use cases are not just limited to these, but these are the top 5 that we are seeing, which is that if you start with the exploration, right, the first thing that people want to do is, well, I have all of this data. If I can just search across this and gather useful information or what I care about, that itself tells me something that I wasn't able to do before. So now this is not just searching across manuals, right? This is now searching where you can search across the data that might be in a Hadoop file system. You can search across data which may be sitting in your warehouse, in some email content repository. So it's searching across all the information or the data that you think might be relevant to gain the new kinds of insights. So just exploring, searching, making that easier, like log data, for example, right? I mean, there's lots of things that can be done to analyze logs, but some very quick returns are attained by just being able to search across logs and get the information out represented visually in a meaningful manner. So search is a very important use case of big data. Again, this was also something that Merv from Gartner alluded to yesterday. This is something that, again, we are seeing a lot of enterprise customers do. Then, of course, everybody is trying to get a 360-degree view of, I just call it 360-degree view of entity. It could be anybody. It could be a customer. It could be a patient. It could be anything. But it's now possible to get that 360-degree view because now the advancements that have been made in the technology make it possible to glean information from different sources, pull it in the right context, and be able to put it in front of the line of business. Same thing from a security standpoint, being able to analyze log data, being able to correlate that with certain interactions that might have been captured, so which is making it more real and more accurate in terms of catching security violations. We talked a little bit about the log data itself from an operational analysis standpoint. And the warehouse augmentation is, if there was one single biggest use case that we are seeing happen everywhere, is where people are trying to really augment their warehouse and use Hadoop as a way to, as an active archive, like I said, as well as bringing in data and really extending or getting that 360-degree view of the data by bringing in all different kinds of data. So these are sort of the typical use cases that we are seeing. And while, and to make all of these happen, Hadoop is a critical part of it. And so that's why when I said that the angle and the focus of my talk is not just the advancements that are being made in Hadoop. I think there is absolutely fantastic work that is happening there, but what else is needed beyond that? So when we look at what a big data platform should look like, Hadoop is a critical part of that platform, but the real-time streams capabilities is an equally important part. Being able to search and across content is an equally important part. So when you look at just the different repositories that are that are emerging, Hadoop is one. There is data that has to be analyzed, which is not even, sometimes there's no relevance to even persisting it. So it's in-memory analytics. And warehouses continue to still play a key role, right? Because there are applications, there are workloads that make sense where you need, where you know the questions and you need those answered in a highly performant manner, right? So that's where the warehouses continue to play an important role. And bringing in the content repositories from which, again, now it's possible to gain insights from, forms like a key part of the big data platform. Now, with all of this, it's pretty critical that if the data just lies in those repositories, then obviously that's not useful. So you need the right kind of tools for the application developers to be able to build applications that now leverage these new technologies. to deploy those applications, to really operationalize those applications. And as those are being deployed, how do you administer, monitor, any alerts that are getting generated, how do you react to those? So tooling is needed for application developers, for the diviners like data scientists, for system administrators, and there are key analytic engines like text analytics, machine learning that are needed. Otherwise, all this data without that analytics capabilities is really of no use. So what this substrate, that is Hadoop, has made possible is it has provided a framework that you can build around it, you can build on top of it. It has made it possible that capabilities like text analytics, machine learning can now run and span all of this framework that is provided by Apache Hadoop, right? So that's why it's become a key component of big data, but there is a lot more than just saying, if you bring in Hadoop in your enterprise, that is not going to perform magic, right? So for the magic to happen, there's a lot more that has to be brought in. More magicians are needed than just one piece. So let's look at a little bit on, I'll just do a quick time check here, on what are these enterprise capabilities. So like when you are ingesting data in a Hadoop file system, right, there is the scoop and the flume. So when you have to do batch loads, that's good. But when you have to do real-time loads with extremely, very high throughput and do some transformations, then streaming kind of capabilities can be used for that. And the traditional, where there is very complex transformations required, then you still need ETL kind of tools to be able to do that, even if the data is coming in a Hadoop file system. And we are seeing customers do that, right? So somebody may say, oh, now you don't need ETL. Well, some of those complex transformations are not possible otherwise. So that doesn't go away. It's just that now you have more options, and based on what you're trying to do, you can pick, you have choices here. Now, once all this data is brought in, there is, obviously this data is stored without tinkering with the fidelity of this data. So, which means that now you can obviously access this data using NoSQL paradigms, but you may also need to filter and analyze and put structure to some of this data, because unstructured data, you can't just analyze it. Otherwise, you could have analyzed a manual just by reading the whole manual. So some information needs to be extracted from it. And those kind of transformations can be done now. So there are text analytic engines that are needed. There are machine learning capabilities that are needed to really understand and predict the outcomes. So with all these kinds of advanced engines, as the results are coming in and as applications are being built, you need very good visualizers to be able to really see and do this interactive kind of analysis with the substrate that is below. And to access this data, there is obviously the NoSQL paradigm is there, but once some structure has been put on this data, which like I said, you need to put some structure to even analyze text. Once data reaches a structured point, that is when you need a structured query language, SQL, on Hadoop. So that is another, I think we've heard a lot about that at this conference. And of course, we at IBM are doing, we have something called Big SQL. And this is basically, each of these slides can be a session, so I'll try to just give a quick overview. It is really bringing ANSI SQL, it's ANSI SQL 2010 compliant, bringing that to Hadoop. So you can, so the administrators can create tables. They can load data into these tables from Hive, HBase, from just comma-separated flat files. They can load data into these tables from other relational databases, and then of course, query these, right? And at this point, there is, I think everybody is trying to solve. There's still more work to be done here. But the key is that you can create tables, you can bring in data from all kinds of sources, you can query that data, and there is ODBC and JDBC drivers being provided so that tools like business intelligence tools like Cognos and MicroStrategy and others can continue to access the data just by issuing big SQL. So the good thing here is that it is, and then it leverages MapReduce when it makes sense, but there are certain kinds of queries where MapReduce, being very batchy in nature, will not give the desired performance. So we have a workload manager. So based on what's the right way to execute that query and what framework to be used, it does that in an intelligent manner. Now, we talked a little bit about text analytics, and I'll jump in the interest of time to how this text analytics it works. So what this is an example where a radio broadcast, so it's voice which got converted into text, and then running through our text analytics engine, there are entities that are being extracted from this, which are really the name, position, and country. So for text analytics, it's important that you extract the entities, and you need natural language processing capabilities to really understand what's a noun, what's a verb, and then you have to understand the context and the semantics, where is it a positive sentiment, negative sentiment, is there a pun intended, sarcasm. So with all of that, right, so the text analytics engine, which we support on top of our Apache Hadoop, we are able to do that. And this can be done on top of Apache Hadoop, but it can also be done in real time with our streaming engine, that as the data is coming in, similar kind of extraction can be done without having to persist this data. So in terms of, as this data gets ingested and comes in the Hadoop file system, then we have our text analytics runtime. So which is what that will do is it's going to parse this text that is coming in, tokenize it, do matches against dictionary, or you can do regular expression searches, and refine that with more rules which are done in a SQL-like language. And once all that filtering happens, then the output, and then to run this, because you have to do it at scale, this could be petabytes of text data. So we leverage the MapReduce framework to do that. So this spawns the mappers and the reducers. And the output of that becomes a JSON. By default, it's a JSON format document. And then you can access that using Pig or SQL, or process it in any way you like. So these things are pretty critical. We have a whole development environment that comes with this, because this is an important aspect of applications that are being built where everybody comes and shows the magic, but there is all this other magic that needs to be done behind the scenes. Again, I think we covered there are lots of tooling that comes or is needed by different classes of users to leverage this big data. And I'll not get into the details, but as Hadoop is becoming critical path in an enterprise, the same rules that you had for governance and security and privacy, all of those apply to the Hadoop world as well. And those things have to be taken into consideration, that who's accessing the data, when did they access the data, do you see any abnormalities there, and if so, then alerts need to be generated. So those are all the kind of capabilities that you need as you get Hadoop in your mainstream in the enterprise. And we talked about one of the use cases being able to archive or offload data into Hadoop. And for that, you have to know what to archive, what's the retention policy, which tables, schemas, and business objects do you move, and when you move them, how do you make sure that what needs to be masked or encrypted. So all those capabilities are something that are provided. Now you can see there are lots of moving parts here. So to put this all together, a Hadoop cluster requires hardware knowledge, networking. You need a lot of skills. And one way to, if those skills are not available, would be to go the appliance route. I think that has been talked about a lot. So there's a lot of breadth of capabilities. We have something called Big Insights, which is available in various editions. We embrace Apache Hadoop, completely pure, no tinkering with that. And like I said, there are lots of capabilities that we have built on top to facilitate the kind of applications that are emerging in the enterprise. So I will conclude here. I had a few more charts, but we are out of time. This seems like a logical point to end this, and to get started on big data. Here are some links. We have Big Data University, a Big Data Hub, which has a lot of information on all of these topics in more details. And the work that is being done by this community is fantastic, fabulous, and we are really here to make that stick in the enterprise by, like I said, we are not building in the Apache Hadoop substrate itself. That's where we want to support the community to do that. So we do contribute back, bug fixes, et cetera, to it. But what we are really doing is building on top and really extending that stack so that these different kinds of applications that we talked about are possible. So thank you very much.